Is it audible?
Yeah.
Good morning, one and all. Myself, M. Kishore, Assistant Professor in Department of Department of Zoology, Dr. B.R. Ambedkar Open University. Respected Vice Chancellor of Dr. BRAOU, Professor K. Sitaram Rao Sir, Register, Director Academic Sir, Dean Faculty of Science, Pushpa Chakrapani Madam. A very good morning all. Today's special guest and expert, respected Professor N. Vijay Kumar, retired, and all directors and dean faculty members and dear students, a warm welcome to all for this program. I am happy to share with you that the Department of Zoology has initiated the webinar series. In next 5 days also we have a series of lectures. And today is the first webinar organized by Department of Zoology, Faculty of Science, Dr. BRAOU. So I am very grateful to Professor N. Vijay Kumar, retired professor from Kakatiya University, for accepting to give a lecture for this webinar. And sir, retired from Kakatiya University, sir got fellowships and done research in Germany also. And sir published national and international journals, and he is very expert in biochemistry and physiology. And today's topic is energy and glucose homeostasis and consequences of its failure. Sir is going to deliver the lecture on biology, especially energy and glucose homeostasis and consequences of its failure. I hope this webinar will be helpful to all. And thanks to university dignitaries for giving this opportunity to conduct the webinar. Now, I request Professor N. Vijay Kumar sir to start the lecture.
Good morning, everybody. Yeah, I first would like to thank the organizers of this webinar for giving me the opportunity. Now, I have chosen a topic, a general topic that is related to zoology, physiology, as well as general health. That is the energy regulation and glucose regulation, and what happens if its regulation fails. So that is my topic today. Yeah, generally, energy is defined as the capacity to do work. Without energy, any organism, whether it may be bacteria, plant, or animal, it cannot survive. So for day-to-day activities and for survival, it requires energy. So they require the energy to stay alive, to do work, to grow, and to reproduce. For all activities, it requires energy. And where from this energy comes? Energy comes from the food. And these are the chief components of the food: carbohydrates, fats, and proteins. Okay, of course, plants, they do not take food, they synthesize food material. Only animals, because we are heterotrophs, we consume food from the other sources. So these are the major sources of food: carbohydrates, fats, and proteins. So they contain energy in the form of potential energy in the chemical bonds. Now, this energy is released when the food molecules are oxidized. For say the organelle which oxidizes the food organelles is mitochondria. So on oxidation in mitochondria, the energy is released and stored in the form of ATP, that is adenosine triphosphate. And this energy is useful for different activities like synthesis of macromolecules, synthesis of other cellular constituents, and for cellular movements like muscle contraction, nerve impulse, and all these things, and transport of molecules, because all cells, they are covered with membranes, and to travel through the membrane, it requires energy, what that we call as active transport. And generation of electrical potentials, say for example, now and also production of heat, because animals, particularly the mammals, they maintain the body temperature at constant level. Now, just here, what are the daily requirements of the food, daily average energy requirement? For males, it is 2,500 kilocalories. And for females, it is 2,000 kilocalories. And what is calorie? Calorie is the unit of measure of energy. And this can be defined as the amount of energy that is required to raise the temperature of 1 milliliter of water, that is 1 gram of water, or by 1 degree centigrade. So this is the, now food supply different energy requirements. And the constants of food, as you know, I have told you, carbohydrates, they provide nearly 50% of energy that is required daily. And then fats, they supply nearly 30% of energy. And proteins, they supply 15% of energy. And they also supply essential amino acids that are required for protein synthesis, because proteins are regularly required for the synthesis. Now, in addition to these energy supplying molecules, we also require vitamins. Vitamins, normally they do not supply any energy, but they are required as coenzymes in different activities for metabolic activities. Now, minerals, you know, they are required in different quantities like sodium, potassium, calcium, and calcium is the chief constituent of bones and teeth. Water. No, water is not a nutrient. It will not supply any energy, but it is required because our body is nearly 60% of water, and it provides a medium for different metabolic reactions. So this is how we get energy from different sources: 55% from carbohydrates, 30% from fats, and 15% from proteins. Now, there are energy stores in the body. Nearly 100 to 120 grams of glycogen, that is carbohydrate, that is polymer of glucose, is stored in liver, and nearly 400 grams in muscles. Fats, they 10 to 20% of the body weight, and it is stored either below the skin, that is called as subcutaneous, and also visceral fat, that is between the organs. Now, proteins, they form 15 to 20% of body weight, and majority of the proteins, they're present in the muscles. No, this just now I told you about the water. Water is, it do not supply any energy, but it forms nearly 60% of our body weight. Now, this is general introduction about energy requirements. Now we come to the homeostasis. What is homeostasis? Homeostasis is maintenance of constant internal environment, is called as homeostasis. Now, for example, in our body, the body temperature is maintained at 37 degrees centigrade. Whether you are in winter, where the temperature may be 10 degrees, or in summer, it may be 45 degrees, but the body temperature remains 37 degrees. So that maintenance of constant internal environment is called as homeostasis. Now, for homeostasis, you see here in the diagram, there will be a set point. As I told you, for temperature, it is 37 degrees centigrade, or for blood glucose, say 90 milligrams per deciliter, or blood calcium, 10 mg per deciliter. So in this way, there will be set points. That is a normal range or normal set point for all parameters in the body, and this is maintained. And when there is a perturbing factor, anything that changes, for example, our body temperature is 37 degrees, but if this is a cold air is there, then automatically the temperature drops. So to accommodate that, again, our body has to produce heat, that is called as thermogenesis. So this perturbing factor is called as a stimulus. This stimulus causes a deviation from the set point. Here the temperature is 37 degrees. And suppose if cold wind is there, the body temperature may go up to 20 degrees. So this change in temperature is sensed by sensors, that is thermoreceptors. And then this thermoreceptor, they send impulses to integrating center. Normally it is a brain or spinal cord or endocrine glands. They are integrating centers. These integrating centers, they analyze the stimulus and take appropriate action. For example, it is cold, automatically our body shivers. It is called as vanakadam. So it produces heat, thermogenesis, and we have a brown fat. This brown fat produces the heat by liberating energy. Similarly, if temperature is very high, then our body sweats and water is produced over the surface. And this water evaporates and cools the body. So this is called as effector organs like the skin or muscles. These effector organs, they change the response to normal returns. It returns to the set point, that is 35 degrees centigrade. And automatically, when it reaches the normal set point, it stops functioning. This loop is called as a negative feedback loop. So normally in our body, all are negative feedback mechanisms. For example, there is a refrigerator. In the refrigerator, we set temperature at 4 degrees centigrade. And there is a thermostat which senses the temperature. When the temperature rises, automatically the compressor starts because the thermostat gives an impulse to start the compressor, and compressor cools down. When the temperature cools down, comes to normal level, that is 4 degrees centigrade, automatically the compressor stops. So such mechanism is there in our body, just like the refrigerator. So now this is what I have told you about all these things. The maintenance of internal environment. These constantly, they are monitored by extracellular conditions and relay this information via nerve signals to integrated center, which is normally brain, which is called as a set point. The set point is analogous to temperature setting in a refrigerator. So whenever there is a deviation, the effector organs, they bring the set point to the normal level, and then automatically it sets up. The effectors are generally muscles or glands. Okay, this is about the general interaction about homeostasis. Now here you can see in homeostasis. So this is the integrating center, whether it is maybe brain or spinal cord or endocrine glands. Now here there is a set point, and if there is a change in set point, the receptors, they detect the set point change, and the afferent nerves convey the information to the integrating center, that is a brain, and brain takes appropriate action by different pathway, by effectors, and then there will be a response, and again it comes to the normal level. This is called as negative feedback loop. Now we will come to energy regulation. So far this is general about the homeostasis. Now in energy regulation, what is energy? Just now I have told you it is anything that is required to do work is called as energy, and energy is supplied by carbohydrates, lipids, and lastly proteins. So here the body weight is controlled by a complex interval, because the body weight is nothing but it is normally, it contains the fat and to small extent carbohydrates and proteins, but which are there present only muscles. So it is a complex interval between the central nervous system, peripheral signals of energy balance from adipose tissue, and the gastrointestinal tract. So the important thing is fat is also an important regulator for energy balance. Now here you can see what are the hormones that play a role in energy regulation. This is the brain, and this is the digestive system, adipose tissue, pancreas, muscles, and liver. Now you have a hormone that is called as ghrelin. This is called as hunger hormone. It is a peptide hormone produced by the cells of the stomach. It functions as a neuropeptide in hypothalamus and stimulates appetite. So the ghrelin produced by these stomach cells stimulate eating behavior. It asks us to eat. The energy is low, you have to eat. Now opposing the action of ghrelin, there is another hormone that is called as leptin. Leptos in Greek means thin. It is a hormone produced by adipose tissue, that is fat tissue, and it inhibits hunger. That its action is opposite to ghrelin. Okay, it inhibits hunger, stimulates metabolic rate, and helps with the long-term energy balance. The main body weight is maintained by this hormone. And obese people, they are leptin resistant. That means the action of leptin will not be there. Now, insulin also plays an important role. In addition to controlling glucose level, insulin controls feeding behavior and energy homeostasis. Insulin inhibits food intake by decreasing the expression of the orexigenic. Orexigenic means hunger stimulating neurotransmitter neuropeptide Y. So in this way, these two are important, ghrelin and leptin. Now coming to the leptin. So leptin is a protein hormone. It is secreted by white adipose tissue. Its secretion is stimulated by insulin, and the amount is directly proportional to the fat mass. If you have more fat, you will get more leptin. It controls appetite and energy expenditure in hypothalamus by alternatively stimulating production of pro-opiomelanocortin, POMC. There is pro-opiomelanocortin and alpha-melanocortin. So these two, they inhibit hunger and inhibiting production of neuropeptide Y and agouti-related protein. These two proteins, they stimulate hunger, whereas the melanocortin and pro-opiomelanocortin, they inhibit hunger. So this alpha MSH binds to the melanocortin 4 receptor, which inhibits appetite, eating behavior, and increases energy expenditure. So deficiency of leptin and its inability to bind to hypothalamic receptors could lead to a positive energy balance. Positive energy balance means storing energy, storing fat, and generating hyperphagia. Hyperphagia means eating more and severe obesity. So conditions such as dehydration, excessive carbohydrate consumption, emotional depression, stress cause leptin resistance. So this is about the leptin. Now coming to the hormone which stimulates hunger, it is called the hunger hormone. It is called as ghrelin, and this ghrelin is produced by, it is a orexigenic. Orexigenic means it stimulates hunger, and it is produced by specialized stomach cells. Now you see here, this is the stomach. When it is empty, it produces ghrelin. So this arrow indicates increase in the concentration of ghrelin produced by the stomach cells, and it causes an increase in appetite. That is, asks us to eat. Okay. And when the stomach is full, the concentration, the secretion of ghrelin decreases and the appetite decreases. So in a way, the stomach dictates us to eat or not to eat. Its orexigenic actions result from activation of a neuropeptide Y. NPY means neuropeptide Y. This neuropeptide Y stimulates hunger, which is present in the arcuate nucleus of hypothalamus. It tells the brain that we don't have enough energy, that we need to eat, and that we need to conserve our energy. So it increases feeding behavior and also decreases the metabolism. So chronically elevated levels of ghrelin are associated with obesity. So obesity means elevation or increased levels of ghrelin or decreased levels of leptin. Energy homeostasis. So in hypothalamus, you have centers which control hunger. So the circulating levels of leptin and insulin signal the long-term energy stores. Leptin, as I've told you, it is produced by fat cells, and it regulates the weight, body weight, and indicates not to eat. So nutrient ingestion triggers the secretion of numerous gut hormones. After eating, the gut, that is the digestive system, releases hormones which are called as glucagon-like peptides, oxyntomodulin, and PYY. These, they suppress hunger because of satiety. That means when the stomach is full, it indicates that you need not eat, stop eating. The satiety signals, short-term or meal-to-meal regulators from the gut, are relayed through the brainstem to the hypothalamus. And in the hypothalamus, the signals of satiety, that is satisfied after eating, are integrated with signals of long-term energy of fast stores, that is leptin and insulin. And then the balance dictates whether eat or not to eat. So these integrated signals then affect appetite and energy expenditure so as to maintain the body weight within a set point. So the set point for body weight is different from different individuals. A person may be 70 kg, another person may be 80 kg. Depending on his own weight, the body weight is maintained. So this is how the leptin integrates. See, if there is a decrease in leptin hormone, see the pro-opiomelanocortin hormones are decrease, and the NPY increases, and energy expenditure decreases, and there is an increase in appetite. So you have to eat more if the leptin levels are down. Similarly, if the leptin levels are high, it inhibits neuropeptide Y. This neuropeptide Y stimulates hunger, whereas this pro-opiomelanocortin and alpha-melanocortin, these two, they decrease hunger. So whenever they are high, they inhibit hunger and increase in energy expenditure and decrease in appetite. So this leads to negative energy balance. So if leptin is low, you have positive energy balance, that is you eat more and there will be fat accumulation. So this is the fat. From fat, you will get the hormone leptin. And this is hypothalamus. In hypothalamus, you have a center that is called the adiposity center. So here the signals are integrated, and then signals are given whether to eat or not to eat. So ghrelin produced by stomach stimulates eating, whereas the leptin produced by this fat, it inhibits eating. So in this way, the hypothalamus in the brain acts as the regulating center for weight balance. So this is in hypothalamus. So for example, if you have more production of anorexogenic peptides, then there will be decrease in food intake and increase in energy expenditure. And you can see here the decrease in the fat tissue. This is the hormone leptin produced by the adipocytes. Now, on the other hand, if the leptin is less, and you can see here there is an increase in food intake and decrease in expenditure, and you will see the increase in fat mass. So the same thing here, different hormones, how they act. So from pancreas, insulin, it inhibits hunger. Leptin inhibits hunger, whereas from stomach, ghrelin stimulates hunger. So, and these two, they're integrated in the hypothalamus, and then they indicate, suppose if you have more ghrelin, it indicates eat more and metabolize less. And if you have more leptin, it indicates eat less and metabolize more. So in this way, you will find energy balance, energy homeostasis. Now this is a mechanism. This is the brain, hypothalamus, adiposity signals, leptin and insulin. This is the nucleus, arcuate nucleus of the hypothalamus. So they inhibit hunger, whereas from stomach, you will get ghrelin, which stimulates hunger. And when you, after eating, the GI tract sends signals via vagus nerve, satiety signals. So these satiety signals and hunger signals are integrated. And depending on the intensity of signals, it stimulates either to eat or not to eat. Now, what is obesity? So this obesity is a chronic multifactorial disease of a complex etiology resulting from the chronic disruption between energy intake and energy expenditure. It's just like bank balance. Suppose if you spend more, then automatically bank balance decreases. Similarly, if you spend less, the bank balance increases. Similarly, here also, if you expend more energy and eat less, the fat tissue decreases. And if you eat more and work less, automatically fat tissue increases. And this accumulation of fat tissue leads to the obesity. So here, these are the different types of foods, proteins, carbohydrates, and fats, and all of them, they're digested and they release amino acids, or these carbohydrates release sugars, fat releases fatty acids, and all of them, they form fuel. And whatever may be the source of energy, if it is in excess, it leads to fatty acid synthesis and causes accumulation of body fat. Obesity is caused by long-term positive energy balance. So if you eat, if there is a change in the energy balance for long period, then there is energy intake more and energy intake less, then fat increases. For example, eating an excess of 200 calories for 10 contributes to weight gain of 200 calories for 10 days contributes to a weight gain of roughly 450 grams of body weight. So if you take just 2% of more in a year, you increase by 2.3 kg per year. So earlier, the environment was called as the leptogenic environment up to 1900s in this, because at that time there were no transport facilities and food was less. That's why the people were thin. This environment is called as leptogenic environment. But nowadays, what is happening? You have more transport facilities, working less, and you are eating more. That's why here you have an environment that is called as obesogenic behavior, obesogenic environment in 2000s. No, obesity leads to, this is obesity, more fat as energy stored in the body, a high body mass index. This body mass index means body weight by height square. So if it is less than 8.5, underweight, 18.5 to 24 kg is normal. That is, BMI is normal. Now, 25 to 29, it is overweight, and 30 to 34, it is obese, and above 35, it is extremely obese. So the same thing in the tabular form. No, the obesity is because of mainly sedentary lifestyle. That means eating more, consuming more energy, and then expending less energy. That leads to obesity. Similarly, here nowadays speedometers are there. Now, if you walk for nearly 10,000 steps per day, it is called as active. Suppose sedentary life means less than 500 steps per day. Low active lifestyle means 5,000 to 7,500 steps per day. And physically active means 7,000 and above. It is called as physically active. So this can be measured by pedometers. In smart watches, you have pedometers. So in this way, as you increase the activity, the energy expenditure increases and you will become physically active and less obese. Now, this is this minus, say, this much of years, this was human beings were food gatherers. Now, in the modern day man, now he's like this. Now, what is the problem of obesity? Now, obesity causes several diseases like, say, heart disease, hypertension, osteoarthritis, cancer, reproductive disorders, obstructive sleep apnea, hyperlipidemia, and type 2 diabetes. So here we discuss just about the diabetes. Now, people generally, what they do is for weight loss, they restrict calories. There is dieting. So an analysis has shown that weight loss clinical trials mediated by lifestyle interventions showed that average weight loss of 5% to 9% in the first 6 months, which backtracked to 3% to 6% in those studies where 40th month data is available. That means even if you restrict calories and again start normal, again the weight comes back. So calorie restriction is not a good measure for losing weight in obese people. So exercise, restricting the energy intake and expending more energy decreases the obesity. Now, this is the type of obesity. This obesity leads to type 2 diabetes. Here, if obesity leads to insulin resistance and then impaired glucose tolerance, then hyperglycemia, and then ultimately it may lead to death. So what is the problem is metabolic syndrome, atherosclerosis, hyperglycemia, hypertension, retinopathy, neuropathy, and all these are the diseases complications of the diabetes. And then now this is about the glucose homeostasis. In our body, normally the glucose is around 80 mg per 100 ml. That is 10 decaliters is normal set point for glucose. So if after a meal, what happens? The glucose concentration increases. What is the stimulus here? The stimulus is the rising blood glucose level after eating a carbohydrate-rich diet. Then automatically this glucose level is sensed by the cells, beta cells of the pancreas, and then they release insulin. So this insulin causes the blood glucose levels to decrease because the glucose goes into liver and is converted to glycogen and glucose into muscles. So in this way, the blood glucose level declines because of the secretion of the insulin from beta cells of pancreas. At the same time, if you don't eat, that is during hunger period, so then what happens? The blood glucose level drops, decreases. So at this time, the alpha cells of the pancreas, they stimulate a hormone called as a glucagon into the blood. This glucagon breaks down the glycogen present in the liver and releases the glucose, and the normal level of this 90 mg per 100 ml is attained. So in this way, the glucose balance is maintained. Here, the brain is not involved. Only the endocrine glands, the beta cells and alpha cells of the pancreas are involved in the regulation of blood glucose levels. Now here you can see, this is the time when you eat a meal, this glucose concentration. See, glucose levels, they rise after a meal, say up to 1.5 hours, 2 hours. Then they fall and they come down to normal level, that is nearly 80 to 90 mg. And here they may go up to 160 mg. So this is normal. So this is because here, after a meal, insulin is produced and glucose levels fall to normal level again. So what happens? See here, this is the glucose. When the glucose levels increase in the blood, this is the glucose in the blood. When the glucose levels increase in the blood because of digestion and absorption, then then these glucose levels, they go absorbed into the liver, where the glucose is converted to glycogen and stored, and also in muscles. The chain increases. Now, this is the action of insulin, how it acts actually. Say the glucose in the fat tissue is taken up by the glucose because it is under the control of insulin. Insulin binds to the receptor and causes a glucose uptake by a channel that is called as glucose T transporter. And here it is used for lipogenesis, that is synthesis of fat. So in the muscles, again, same, there will be insulin receptor. When insulin binds, the glucose is taken up and glycogen synthesis. Similarly, here also in liver, the glucose is converted to the glycogen synthesis. So this insulin helps the glucose transport into the cells and conversion into either fat in this adipose tissue or glycogen in liver and muscle tissues. Now you have different glucose transporters for transporting glucose, because glucose is water soluble. It cannot pass through the cell membrane. That's why it requires different transporters. Now this is the mechanism how the insulin, this is the insulin receptor. When you eat, the insulin is released, it binds to the receptor and causes the glucose transporters, which are present inside the cell, to the glucose is taken up by these glucose receptors. Normally, these glucose T transporters, they're insulin sensitive, they're present inside the cell, and then they come to the surface and they take up more glucose. So, and this insulin signals pathway, effect on lipid metabolism, effect on growth, and effect on protein metabolism. So this is the insulin sensitive glucose T transporters. The same mechanism. So this is the insulin receptor when it binds. So these are the vesicles containing the glucose transporters which come to the surface and take up more and more glucose. Now here I have told you that the brain is not involved, only the glucose concentration is involved in the release of insulin. So this is the pancreatic beta cell. So when the glucose enters, it causes an increase in the ATP because metabolism is increased, and it inhibits a channel that is called as potassium channel. Because of that, there will be depolarization. And because of this depolarization, calcium enters, and this calcium causes the release of the insulin granules present in the beta cells. And this insulin binds to the membrane receptor and then causes the uptake of glucose. Now, what happens if the insulin is not there? Now, this is the meal eaten. Now, you see here, After a meal, normally the level should come down after 2 hours, but here it is remaining high because of the problem is the insulin is not produced, so glucose levels stay high. So this condition is called as a diabetes. Now, glucose in the blood, because there is no insulin, it is not taken up, and then they see there is no synthesis of glycogen or fat in body tissue. So glucose content rises to dangerous blood levels in blood. So in what happens in a fasting state? In fasting state, pancreas releases a hormone called as a glucagon. This glucagon binds to receptor and causes lipolysis. That is a breakdown of lipids and fatty acids are released for energy metabolism. Similarly, in muscle, glycogenolysis, the breakdown of glycogen, and the glucose is used for glycolysis. And in the liver, it causes glycogenolysis and the glucose is released into the blood so that blood glucose levels are maintained. So this action of glucagon is quite opposite to that of insulin. Insulin causes all these effects in opposite direction, whereas the glucagon causes in forward direction. Opposite, antagonistic. Glucagon and insulin are antagonistic in action. So this is the mechanism how glucagon releases the glucagon is released by low glucose concentration. When the glucose concentration is low, glucagon is released. When the glucose concentration is high, the glucagon is not released. So this is the beta cell, and this is the alpha cell. When the glucose is high, insulin is released. And you see here, the glucagon is not released. This is the mechanism. Now, what is the glucose homeostasis chart? In the condition, when there is high blood sugar, the receptor, glucose transporter, control center, beta cell of pancreas, effector, insulin, result glucose uptake by muscles, fat tissue, and lowering of blood glucose level. So when the glucose level is low, it is also glucose transporter, but the control center is alpha cell, and effector is glucagon. And here the result is the breakdown of glycogen in liver and raising the blood glucose level to normal level. Now this is about the types of diabetes. So in normal man, there is Gesunder Mensch means normal human being. The pancreas secretes insulin and it is insulin binds to receptor and a glucose is taken up. In type 1 diabetes, insulin is not released because the beta cells are destroyed by certain diseases or autoimmune disorder. Insulin is not released, and because the insulin is not released, it cannot bind, and this glucose transporter cannot take up glucose because it remains inside. In type 2 diabetes, insulin is produced, but there is a defect in the receptor. So even though insulin is there, receptor is defective. That's why the glucose transporter remains inside the cell and glucose is not taken up. So this type 1 diabetes is called as early onset diabetes or juvenile diabetes. Whereas normal diabetes is type 2 diabetes. Normally all people, they have type 2 diabetes, which affects persons after say 40 or 45 years of age. The same thing, diabetes mellitus type 1, known as juvenile diabetes. Type 2 is known as maturity onset diabetes mellitus. Age of onset usually occurs in children. This is after 35 to 40 years. It accounts nearly 10% of the cases of diabetes, here nearly 80%. So causes of diabetes, absolute deficiency of insulin. Here, relative deficiency insulin caused by dysfunction of beta cells or due to insulin resistance, that is a defect in the receptors. Now, what are the causes of type 2 diabetes? Obesity is believed to account for nearly 80 to 85% of the risk developing type 2 diabetes. So obese people are up to 80 times more likely to develop type 2 diabetes than normal people. And genetical, if one of the parent has type 2 diabetes, there is a chance of 15%. If both the parents have type 2 diabetes, there is 75% chance of getting the diabetes in having high blood pressure or raised cholesterol levels, stress, urbanization, or being South Asian, say Indians, particularly we are also, and smoking. So these are the factors cause diabetes. Renal threshold of glucose means in diabetes, what happens? The concentration in the blood increases by 160 to 180 mg per deciliter. And then it is, if it is becomes more than 160 or 180 degrees, 160 or 180 degrees automatically, then it is released or in the urine. That's why you'll find glucose in urine, glucosuria. So these are the countries where we have diabetes on all these countries. So this is India, these many people, they are having diabetes, and there may the possibility of increasing diabetes by nearly 100% in coming future. So what is the importance of blood glucose? So blood glucose normal range is from say 60 to 90. So it is important because it is universal fuel for microbes to humans. It is sole major fuel source for the brain. And brain alone requires 120 grams of glucose per day. And these are the levels of glucose. Random glucose should be 200, or fasting 100 mg, after meal 140 mg. So these are the all levels. If it is in fasting, it is 100 to 125, it is called pre-diabetes, or more than 126 is called diabetes. Sorry. So the best test for testing the diabetes is HbA1c test. So normal level is excellent control. Up to 5.8 HbA1c is normal, and above 5.8 is pre-diabetes, and above 6 you can say it is diabetic. So the current load of diabetes in India is expected to increase by 170% in the next 20 years. Now, what are the symptoms of diabetes? So it affects brain. Even in the smell, you have acetone body smell. Okay, I'll finish. The different body parts are affected. Mainly the affected body parts are brain, that is called cerebrovascular disease, eyes, that is called diabetic retinopathy, then heart, coronary heart disease, and kidneys, diabetic nephropathy, and nerves. So it is called as polyneuropathy. So these are the diseases caused by the disease. So these are the normal retina, and how you can see when you are normal. This is diabetic retinopathy. You can see here blind spots where you cannot see clearly when you have diabetes. Maculopathy. So macula is affected. Macula is the center part of the eye. So when you have diabetes, you can see here, this is the part. And it also causes cataract. In nephropathy, you can see here the damage to the Bowman's capsules and leakage of protein. And nephropathy, because of the nerves are damaged, you cannot feel sense, and you will get easily injured, and you will be having problems. So type 2 diabetes cannot be cured. First line of treatment is diet modification and regular exercise. Diet high fiber, low carbohydrate, and low GI foods, such as vegetables, beans, and brown. So these are the composition of all these things. So these are the things which you have to do when you have diabetes. Either in type 1, you can take insulin, and you have to eat balanced diet and exercise. Okay. So about the glycemic index. What is glycemic index? Glycemic means the scale that ranks carbohydrates by how much they rise blood glucose levels. Some foods, they rise blood glucose was very fast when compared to other foods. For example, if you eat white rice, it raises blood glucose at faster rate when compared to the brown rice, or you can say. So that is, glycemic index is the indicator actually. So for example, you take glucose, it is 100, and white rice, say, will be having 56 like that, and brown rice, it may be 40. So if you take glucose, it rises immediately, 100%. If you eat white bread, 70%. And if you eat spaghetti, 41%. That means this is having less glycemic index and compared to bread. So the foods which having less glycemic index are important to control the diabetes. So this is high glycemic index foods. This is the low glycemic index foods, how they raise the blood glucose levels. So high glucose level foods are, you can say chips, biscuits, cakes, ice creams, these things, all these are having high GI values. Whereas these are having low GI values like basmati rice, vegetables, lentils, pasta, whole grain, oats, oranges. So these should be eaten more and they should be eaten less for people with diabetes. See, white rice having nearly 70, whereas the brown rice, it will be having between 56 to 69. No, why glycemic index is different? Because the brown rice, it is covered with bran and it is not easily available for enzyme activity. That's why it is digested slowly and the glucose it is slowly. So benefits of low GI diets. Are there any documented or benefits following low GI? Yes, they decrease body weight, decrease blood glucose levels, decrease the risk of type 2 diabetes, decrease cholesterol levels, and decrease heart disease risk. So these are all benefits of the low GI foods. So what should you eat? A balanced diet, having all constraints like lean protein, complex carbohydrates, and unsaturated fats. Unsaturated means which are liquid at room temperature. Oils are better than butter and ghee. And at least you should do exercise for 150 minutes per week. Exercising 150 minutes per week decreases diabetes. So here you can see eat to live and not live to eat. And to lengthen your life, lessen thy meals, to eat less so that your life is increased, and eat less and to live more. This is the motto. So this is what I wanted to say about the regulation, energy regulation, glucose regulation, failure of the regulations of glucose as well as the energy, and the consequences. In that I have taken only one diabetes. There are several diseases. I have taken only one diabetes, and how to control them, and what are GI foods, and how they are useful. Thank you. If you have any doubts, I can clarify. Hello.
Thank you, sir. Thank you for giving this wonderful lecture. And this is questionnaire time. Dear participants, have you any doubts, any questions you can ask?
If there are no questions, I thank the audience for their patient hearing. And I also thank the organizers for giving me this opportunity, particularly Professor Sitaramara Garu, the Honorable Vice Chancellor, and Purna Srinivas. Thank you. Any doubts? Healthy persons, normally healthy persons means if they are exercising and they're having normal diet, normally they don't get any diabetes. The diabetes is mainly the problem of the people who don't exercise and eat more and having more, that is obesity. The energy imbalance leads to the obesity, and the obesity leads to diabetes. Not only diabetes, but several disorders. Normal persons, Normally, that is, if you are doing regular exercise and your body weight within the normal range of body mass index, the diabetes is not a problem. But again, there are factors like genetic factors. As I have told you, if one parent is having diabetes, you have a 15% chance of getting. If your both parents are diabetic, you have 85% chance of getting. So it is genetical and also depends on diet. Sugar-free, not only sugar. See, obesity is caused by taking any type of food. For example, even if you eat more protein, then the amino acids that are released, if they are in excess, they are converted to fat. Not only sugar, you should restrict the calories. For example, if you require 2,500 calories, you should eat only that much, not more than that. Diabetic, yeah. Nephropathy means because diabetic neuropathy, damage to the nerve endings, and because the loss of sensation, you may hit different objects and get injured. And normally in diabetic people, the injuries are not normally healed. That's why sometimes people infection lead to infection and amputation of legs. One leg is not necessary. It may affect both the legs or one leg depending on the injury. If the leg is injured, then it is damaged, and if it is infected,
Have you any doubts?
Hello, Kishore. Can you hear me?
Yes, sir. Hello. So, dear students, have you any doubts? Yeah, thank you all. Now, Dr. Homeostasis sir give vote of thanks.
Hello. Sir, V.A. Kumar sir, first of all, I wanted to say sorry because I'm held up at Necklace Road because of a breakdown in vehicle, and probably I missed your most of your lecture, though I was online. And thank you very much. Thank you very much for your extensive lecture. And this lecture will surely benefit the students, but the strength is very poor. However, it is recorded in YouTube and they can have it. And thank you very much, sir. Very much thank you. And thank you, Kishore, for taking what you call charge of recording and welcoming Vijay Kumar sir and conducting the proceedings in a very good manner. Thank you.
So thank you all. Tomorrow we have one more webinar. So we can meet tomorrow through the webinar. Thank you and thank you all.
It is a continuous process till Saturday. Except on 22nd, there is no lecture. But tomorrow onwards, you have lectures. Continuously 5 lectures. And I need all the students take the advantage of participation, because today only 20 students have participated. And I request all the students to take the advantage to participate and get the benefit. Because once you listen the lecture in live, and you cannot skip that. If you listen in YouTube, you can skip that and you cannot have any doubts and all. So better you attend. I have posted in all the groups, almost 1,000 students are there, but only 20 have come in. Okay. Thank you.